Yes. Now for the y-intercept, we can see x is 0, x is 3, x is 3. And for the y-intercept, we need to set x is 0 in the above equation. So you can see x is 0, x is 0, x is 0. So what is the answer? Y is 0. So simply y-intercept is 0, 0. Now, symmetry. Third point is we will check symmetry. Symmetry means we need to check function is even or odd. So here we will check x will be replaced by minus x. In the place of x, we will substitute minus x in the given function. So we can see here it's not same as the original function, not a minus. So it's not even, not odd. Not even, not odd. What is the meaning? Not even, not odd. What is the meaning? No symmetry. So here now we have 3 points. We have calculated domain, second intercept, and third symmetry. Now we will have asymptotes. We all know we have two asymptotes. First is a HA, horizontal asymptotes, and second is a vertical asymptotes. So for horizontal asymptote, we must put in the factor in the given function limit x goes to infinite. If we have some limit here, not infinite, not minus infinite or positive infinite, so we can say some this limit is called the HA. But here we can see if we put x is infinite, we have answer infinite. Here if we put minus infinite, we have minus infinite. Infinite minus infinite, what is the meaning? That means there is no HA. What is the meaning? No horizontal asymptotes. Now we are going to find VA. No VA, because there is no number A such that we can put and we will get limit infinite. So it's opposite of HA. In HA, if we get infinite answer, so that means there is no HA. But in VA means vertical asymptotes. If we have any number which if we put as a limit and we will have answer positive infinite or negative infinite, we can say vertical asymptote. But there is no. Here you can see there is no number which we can put as a limit. So we can say no VA. Now move increased or decreased. How to find increased or decreased? Means we have to find the sign of first derivative. First derivative. Sign of first derivative means we have to find the derivative. So here you can see 6x square first derivative minus 24x, 18x, so x derivative of x is 1, so plus 18. Now how to find the critical number here? For the increase or decrease, we need to find the critical number. So that means we need to put first derivative equals 0. 6x square minus 24x plus 18 equals 0. We can take here 6 as a common, and x now inside the bracket we can see x square minus 4x plus 3 equals 0. X equal, so after solving this one we will have x is equal to 1 and x is equal to 3. This we can solve by factorization, or we can use calculator mode 5-3. So if we use mode 5-3, it will give you x minus 1 equals 0, x minus 3 equals 0. That means x equal 1 and x equal 3. Or you can also solve without calculator, means you need to factorize. So what is the critical numbers here? X is 1, x is 3. If first derivative exists everywhere because it is polynomial. Now study the sign of first derivative before and after the values we got in step 1. Means at 1, before 1 and after 1. Before 1 and after 1. At 3, before 3 and after 3. So you can see at 1. Now before 1 what we can take? We can take 0. So if we put f first derivative 0, what is the answer? What is the answer? F first derivative 0. What is the answer? If we put here 0, 0, so we have 18. But here, what is the matter? Sign. What is the sign of 18? Which is positive. That is very important. Positive. So before 1, what is the answer? Positive. Now after 1, we can check at 2. So if we put 2 in place of x, so after calculation we have minus 6. So what is matter here? Negative 6. Negative means here negative. Here positive, here negative. You can see before 1 positive, after 1 negative. Same as we can calculate at 3, but at 3 you can see before 3 means before 2 we already calculated, which is negative. So we don't need to calculate again, just we need to calculate after 3. After 3 means we need to calculate at 4. So we are calculating at 4 means we have to substitute x equal 4 in this equation. So we have positive. So positive here, negative here, positive here. So what is the increasing? Increasing means in which range where function is positive. So you can see this is positive. What is the meaning? It goes up to negative infinite. So we can write negative infinite to 1 and is increasing, and also increasing we can see 3, and it goes up to, there is no limit, so it goes up to positive infinite. So 3 to infinite, increasing minus infinite to 1 union 3 to infinite, increasing. Decreasing only we can see this interval means which is negative, that is called decreasing, which is negative. So 1 to 3 is decreasing. So we in the drawing curve we can see minus infinite to 1 and 3 to infinite is increasing, 1 to 3 is decreasing. Now move to local maxima and minimum values. We can see again we have to calculate local maxima and minimum by first derivative. So by first derivative we can go back to the slide. No, just we checked it here. F1 is 8. If we put F1, because at 1 it changes from positive to negative. At 1, before 1 positive, just last slide we checked it, before 1 positive, after 1 negative. So positive to negative, you can see here, just positive to negative. What is the meaning? 1 at 1 it is maximum. Same as at 3, negative to positive. Negative to positive means at F3 it is minimum. Now what is minimum? What is maximum value? What is minimum value? So F1. So in the given function we will substitute x by 1. We will replace x by 1. So if we calculate in the given function, just replace x by 1, we have 8. Is a local maxima at 1. Same as I just told you, f at 3 it is local minima. But local minima means we have to calculate what is the value. We will calculate in the given function at x is equal to 3. X will be replaced by 3. So answer is 0. So here you can see local minima at 1, answer is 8. This is local maxima. 1 at 1, answer is 8. This is local minima at 3, answer is 0. So we have checked local maximum and minima also using first derivative. Now concavity and point of inflection. For concavity, we need to check the sign of double derivative, second derivative. So first derivative we already calculated in the last slide. Now we have to find the second derivative. How to second derivative? We have 12x minus 24 and equal 0. What is the step? For concavity and point of inflection, we need to put second derivative equal 0. So if we put equals 12x minus 24 equals 0, x equal 2. Now study the sign of f prime before and after 2. Now finally we have curve for sketching. You can see here increasing minus infinite to 1 and then decreasing. This is 1 point, then decreasing 1 2 3. You can see this is x point 1 decreasing until 3, 1 2 3, and then again 3 2 up to infinite. It goes infinite, it goes up to infinite. So 3 to infinite increasing. What is increasing? Negative infinite. This is negative infinite to 1 increasing, and this portion 1 to 3 is decreasing, increasing, and this will be decreasing. And you can see this point is 1 is called local maxima. What is the value? 8. 8 means this is y value at 1, x is 1. Same as local minima at what point? At 3, x is 3, but y value which is 0. So local maxima, local minima, this is increasing, this is decreasing, this is increasing, and there is no symmetry, we already checked, and concave up, concave down, we already check here. So this is the final sketching of the curve.